How an earthquake occurs. The Earth's tectonic plates are in motion. This movement creates forces called stress that push and pull the rock within the Earth's crust. Stress can cause rock to break and release stored energy in the form of seismic waves. These waves travel through the Earth and an earthquake occurs. The point where the rock first breaks is called the focus of an earthquake. The point directly above the focus on the Earth's surface is the epicenter. After an earthquake event, smaller earthquakes called aftershocks often occur near the focus of the original earthquake. Types of stress in crustal rock. There are three types of stress that occur in the crustal rock: tension, compression, and shearing. Over long periods of geologic time, stress causes the Earth's surface to slowly change. When two tectonic plates are moving away from each other, tension pulls and stretches rock. When two tectonic plates are pushing toward each other, compression squeezes rock, causing it to fold or break. Shearing stress occurs when two blocks of rock are pushing in opposite directions. This sliding motion can cause rock to change shape or break. Faults in the Earth's crust. A fault is a break in the Earth's surface that is created when crustal rock breaks and the rock surfaces move past each other. Most faults occur along tectonic plate boundaries. When a fault forms, the block of rock that is above the fault line is called the hanging wall, and the block below is called the footwall. A normal fault is formed when tension causes the blocks of earth to pull apart and the hanging wall moves down relative to the footwall. A reverse fault is formed when compression pushes the blocks of earth against each other and the hanging wall moves up relative to the footwall. A strike-slip fault is formed when blocks of rock slide past each other and experience shearing stress. This type of fault is usually found at tectonic plate transform boundaries. How Earth's surface changes. When two plates are pushing against each other, rock can fold due to compression. An anticline is an upward fold that forms arches. A syncline is a downward fold that forms valleys. Divergent plates often cause the formation of two normal faults in a block of rock. The downward movement of the hanging walls causes the rock in between to move upward. This stretching of the crust forms fault block mountains. Large areas of flat land and rock, called plateaus, are uplifted by plate movements that create stress in the crust. Seismic waves. When crustal rock breaks, stored energy is released in a single massive event called an earthquake. The vibrations that travel through the Earth are called seismic waves. A seismograph detects and measures three types of seismic waves. P waves and S waves travel from the focus of an earthquake through the Earth's interior. When the energy reaches the surface of the crust, surface waves are created. P waves, or primary seismic waves, are the fastest moving waves. They travel through solids, liquids, and gases. The pulsing of P waves causes rock to move back and forth, first compressing and then stretching the rock. S waves, or secondary waves, are slower than P waves and can travel through solids but not liquids. S waves move in an S pattern, creating shear stresses that cause the crust to move from side to side and up and down. The slowest and most destructive seismic waves are called surface waves. One type of surface wave travels in a circular motion, moving the surface up and down. Another type causes back and forth motion. Seismographs are machines that detect and measure seismic waves caused by earthquakes. A seismogram is the tracing of an earthquake's motion. The arrival time and magnitude of each type of seismic wave is recorded in a seismogram. Seismologists use the P and S wave arrival times to calculate the distance between the location of the seismograph and an earthquake's epicenter. The more time that passes between the arrival of the waves, the greater the distance from the epicenter. Readings from 3 different seismograms are needed to determine the epicenter of an earthquake. Circles are drawn indicating epicenter distances. The intersection of these circles is the location of the epicenter. The strength of an earthquake is recorded on a scale of 1 through 10, where 1 is the weakest and 10 is the strongest. This is called the Richter scale and was developed in 1935. The Richter scale is logarithmic, not linear. The amplitude of waves on a seismogram is 100 times greater in a magnitude 7 earthquake as compared to a magnitude 5 earthquake. The amount of energy released between each level on the scale increases at an even greater rate. The Mercalli scale is used to measure an earthquake's intensity as it relates to the amount of damage the earthquake causes. Locations closer to the epicenter typically have a higher score on the Mercalli scale. Earthquake safety. The length and intensity of an earthquake determine the amount of destruction it can cause. Landslides, tsunamis, and shifting ground caused by strong earthquakes can result in significant damage to buildings, highways, and city infrastructures. Scientists predict the risk of future earthquakes by studying the locations of faults and analyzing the information from past earthquakes. Some places, such as the western coast of the United States, are at higher risk for earthquake activity than other locations. Buildings in earthquake-prone locations are constructed to better withstand the motion caused by seismic waves. Steel cross braces, flexible pipes, and shock absorbers are some of the technologies being used. If an earthquake occurs and you are inside a building, crouch under a table or doorway away from outer walls and cover your head and neck. If you are outside, go to an open area that is away from power lines and buildings and lie face down.